Have you at any time reviewed whether we're genuinely alone in the universe, or on the other hand assumed there's something different to our reality other than whatever we see? Imagine what is going on. Consider the possibility that the James Webb Space Telescope at last shows that we live inside a black hole. Join us as we figure out more about this world and bring you news that will make you question all that you assumed you knew about the universe. So, what precisely are black holes? They're similar to something out of a spine-chilling thriller. Sure, you may have seen them in science fiction films, but what's much more upsetting is that they're not just a fictitious concept. According to well-informed specialists, black holes in space are actually huge amounts of matter packed into an inconceivably minuscule region. Imagine a star a few times more gigantic than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been entranced by black holes for quite a while. At first, they studied objects in space so large and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. It is not easy to identify black holes, as they emit no light. However, researchers have found ways to interpret their presence by noticing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce intense light emissions, and even affect the formation of new stars in some regions, while suppressing it in others. So, how do black holes form? Picture this. Stars, once bright and shining, meet their searing end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it implodes under its own gravitational force, forming a black hole. As these massive stars collapse, something surprising happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours at times. When two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, it creates an incredible nightmare that resists understanding. Researchers have been wrestling with the size of these astronomical phenomena for a long time. Black holes come in two sizes, large and small. However, there's a bit of a misconception about them. Small is relative when it comes to black holes. Extremely large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a tremendous number of black holes that could swallow anything in their way. But wait, there's more. Very large black holes exist at the extreme end of the spectrum. They are millions, if not billions, of times greater than the Sun. These live at the centers of large galaxies, including our own Milky Way. They appear like a massive dead space pulling everything toward them. The prestigious physicist Stephen Hawking talked about black holes throughout his life. His theories were well established, but some of his ideas proved challenging to confirm due to a lack of cutting-edge technology. Yet now there's hope on the horizon. Not too far off, a single revolutionary instrument is changing everything. It's known as the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a demonstration of human ingenuity. Sure, we've launched other space telescopes before, and they've done their job well, but this rare machine is on a level that is truly extraordinary. The JWST makes the Hubble, which has served us for so long, look like a basic tool in the universe. The retail cost of this cosmic wonder is an astounding $1 billion. Yes, you heard that right, an eye-watering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with massive contributions from over 300 universities. However, we shouldn't forget the risks that come with such a monumental undertaking. I understand this isn't an endeavor for the faint of heart. The JWST is venturing into an unknown world, stretching the boundaries of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several groundbreaking achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its enormous 5-layer sunshield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after calibration and adjustments, the telescope is almost ready for full operation. One of the most exciting parts of the JWST's mission was when NASA announced it had captured its first major pictures of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light, collected by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory adjusts the individual areas of the primary mirror, it will begin the process of stacking images on top of each other to create one clear view. Thanks to its sophisticated technology, the JWST will assist scientists in studying the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a time known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge once again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are extremely challenging to detect due to how they interact with their host stars. Strong observations can now closely study these planets, allowing scientists to examine their atmospheres and investigate the conditions necessary for life. The JWST's capabilities will help researchers better predict whether specific planets might be habitable. Beyond studying planet formation, researchers focus on these worlds to understand how matter is organized on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today, billions of years later. One of the JWST's goals is to look back at the earliest galaxies to better understand how they evolved. Scientists are also trying to determine how we got the variety of galaxies we see today, as well as the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what? It has found compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the goths of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just interesting because they could form the building blocks of life, but also because they help science track star development. When bright radiation hits these PAHs, they become energized and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument. This is often a sign that there are some hot, energetic stars nearby. But hold on for the surprising twist. Astrophysicist Ismael Garcia Bernard from Oxford University decided to examine 3 intriguing galaxies, NGC 6502, NGC 731, and the Stephan Quintet, as well as NGC 749. These galaxies are millions of light years away, in the depths of darkness. What Garcia Bernard found will send chills down your spine. In those central regions where the black holes reign, he noticed an overflow of PAHs. Sounds interesting, right? Well, here's where it gets chilling. The radiation near these massive black holes changed the structure of the PAHs, transforming them into larger, electrically neutral forms of themselves. The smaller, electrically charged PAHs disappeared into nothingness, being consumed by the very darkness. However, the larger PAHs survived, finding shelter inside thin, dense gas clouds. It's as though they found their own protective cover against the fury of the black hole's pull. Now, you might ask why this matters. Well, for space scientists who rely on PAHs to trace star formation, it's a big deal. Star-forming regions are often completely flooded with electrically charged PAHs. If those particles are destroyed near black holes, tracing star formation becomes a real challenge. But don't worry, our dedicated space scientists aren't backing down. Garcia Bernard and his team are eager to dig deeper into this dark abyss. They want to study more galaxies, each with its unique twist, to uncover the mysteries of how these extraordinary PAHs survive in such extreme conditions. Not to be outdone, here's another game-changing discovery from the James Webb Space Telescope. It has identified what may be the oldest black hole in the universe. This giant beast is an incredibly massive black hole, weighing in at a staggering 10 billion times the mass of the Sun. The JWST managed to identify it by detecting faint glimmers of light tracing back to the very dawn of history itself. This eerie, foreboding discovery was made at the center of a young galaxy, just 570 million years after the universe was formed. And get this, cosmologists believe there may be even older black holes hiding in the depths of space. It's fascinating but unsettling to think about what other discoveries might be out there, waiting to be found. One thing is certain. The James Webb Space Telescope is giving us a glimpse into the darkest corners of the universe, and what we're uncovering is truly awe-inspiring. The discovery of the oldest black hole in the world has sent shockwaves through the scientific community. This massive monster could very well be one of many black holes that existed during the early stages of the first light, a time that began around 100 million years after the Big Bang, when the universe was just a billion years old. Cosmologists are baffled by the sheer number of these black holes and how they managed to grow to such titanic sizes. However, the scientists who discovered this latest black hole published their findings on the preprint server AR14, and the paper is yet to be peer-reviewed. Leading researcher Rebecca Larson, an astrophysicist at the University of Texas at Austin, believes there could be many more black holes waiting to be discovered. She expressed that the James Webb Space Telescope is allowing us to explore cosmic history in a way that was previously unimaginable. She's excited to see what else the JWST will reveal, as it is poised to uncover the vast mysteries of the universe. Who can say with certainty what other marvelous, priceless cosmic surprises await us in the vastness of space? The universe is filled with unique experiences just waiting to be unraveled. With each new discovery, we inch closer to uncovering its dark and astonishing secrets. As we dig deeper into the universe, black holes continue to unveil the intricate complexities of our world. Their formation isn't just the result of dying stars. They can also arise from the merging of neutron stars and other massive objects. This cosmic impact leads to surprising phenomena, such as gravitational waves, ripples in space-time detected by observatories like LIGO. These waves provide insights into the violent processes happening in the universe, including those that create black holes. The search for dark matter also intersects with the hunt for black holes. Dark matter is a mysterious substance that makes up a significant portion of the universe's mass, yet it remains elusive to current observational methods. Some researchers speculate that primordial black holes, which formed shortly after the Big Bang, could be responsible for dark matter. If true, this connection could provide a pathway to unlocking one of the universe's greatest secrets. However, the James Webb Space Telescope isn't limited to studying black holes. It may also observe the atmosphere of exoplanets in incredible detail. By analyzing the light that filters through a planet's atmosphere as it passes in front of its star, scientists can identify chemical signatures indicating the presence of water, methane, and possibly even signs of life. The JWST's infrared capabilities allow it to peer further back in time than ever before, capturing light from the earliest galaxies and stars. This ability is a game-changer for researchers eager to understand galaxy evolution and the conditions that led to the universe we inhabit today. As we continue to push the boundaries of our understanding, the connection between black holes and the structure of the universe remains an enthralling mystery. Each new discovery brings us closer to unraveling the essential nature of reality, revealing a universe that is without a doubt more complex and interconnected than we ever imagined. As we explore deeper into the cosmos, the discoveries enabled by the James Webb Space Telescope are pushing the limits of our understanding. One intriguing question that has emerged is whether black holes might actually be connected to the fabric of spacetime in ways we haven't yet fully understood. Some theories propose that black holes could be portals to alternate dimensions or even to other universes, a concept that feels like pure science fiction, yet it's being seriously considered by physicists. The JWST's incredible precision and ability to look back billions of years allows us to study galaxies in their infancy, potentially revealing how these cosmic giants grew to their immense size. By examining the properties of the first supermassive black holes, researchers hope to uncover clues about how these entities came to exist so soon after the Big Bang. The JWST's sensitivity to infrared light enables us to observe phenomena that were previously hidden from view, providing a clearer picture of how early galaxies and stars interacted with black holes. The telescope's advanced instruments can also help scientists refine models of cosmic inflation, the rapid expansion of the universe just after the Big Bang. By capturing faint signals from the early universe, the JWST has the potential to answer some of the most fundamental questions in cosmology, including how matter and energy were distributed in those first moments and how galaxies, stars, and black holes formed over time.